Hello everyone, welcome to Dr. Ravi's Academy. In this video lecture, you will be understanding the introduction, the various topics of introduction of engineering mechanics. So this particular course is useful for BTech program of mechanical engineering, civil engineering, and those who are writing GATE examination also it is useful, and IIT first year BTech also it is useful. And let us look at the topics of today's lecture. First of all, we will be defining what is meant by mechanics, and then engineering mechanics, and we are looking into outline of engineering mechanics, and finally the content of the syllabus we are going to discuss in detail. Now, let us discuss the first topic, that is what is meant by mechanics. As you know, mechanics it's a branch of physics. It's a branch of physics, and in which we are going to discuss, or you are going to analyze about the forces. You are going to do a rigorous analysis of the forces, and that unbalanced forces. If you have unbalanced forces, that leads to the motion of the body, and if it is maybe leads to the state of the body may be at rest. That means this leads to the effect of the forces is either it may be rest or it may be in motion. Here, mechanics is the branch of physics in which we are going to do rigorous analysis of the forces, and the effect of the forces may be the body at rest or the body may be in motion. This is the definition of mechanics. Now let us look at the second definition, that is engineering mechanics. Short form of this engineering mechanics is EM. Here we are going to apply the applications of principles of mechanics to solve the engineering problems is called engineering mechanics. Here we are applying, so we call it as applications of principles of mechanics to solve engineering problems. To solve engineering problems is called engineering mechanics. So that means here the basic concept is mechanics only, but you are going to apply to a engineering system to solve that particular problem. That is what is engineering mechanics. And let us see the outline of engineering mechanics. What exactly it includes, outline of EM. Let us look at that. EM is broadly classified into two important branches. That is, it is mechanics of solids. If the body is a solid body, the other side it is mechanics of fluids. If the working media is a fluid, this mechanics of solids are further classified into, you may have that particular solid may be a rigid body. It's called rigid body mechanics. If it is a deformable, means it is a flexible, then it is called deformable mechanics of deformable bodies. So mechanics of rigid bodies, it is mechanics of rigid bodies, and mechanics of deformable bodies. So this is what exactly mechanics of rigid bodies, also known as engineering mechanics. Your mechanics of rigid body is also called engineering mechanics. That is also called applied mechanics, and it is even called as classical mechanics also. So this is what exactly the subject EM, engineering mechanics. The other side, if you consider the deformations, you're assuming that the body is rigid under the action of the forces. If the body is able to retain its shape and size under the action of the forces, that particular body is called rigid body. And the mechanics related to that means you are going to consider only the external effect of the forces. That's what is your EM. Mechanics of deformable bodies. This subject is also known as familiarly by mechanics of solids, and very well known it as strength of materials, and in IITs it is known as mechanics of materials. So these are the titles of the subjects known familiarly. So here engineering mechanics are further classified into your statics and dynamics. Here statics says that if the body is in equilibrium under the action of the forces, the body is at rest position under the action of the forces. That's what is called statics. And dynamics means the body is in motion. And this dynamics are further classified into two important streams, that is kinematics and kinetics. It is kinetics. Kinematics is nothing but geometry of the motion. Without unbalanced forces, motion will not exist. But we are ignoring the root cause for the motion, that is forces, and we are analyzing, and that is called kinematics. If you consider the forces as well as the effect of the forces motion, and that particular problem is we are going to discuss in kinetics. Again, to solve the kinetics problems, we have three methods, and these three methods are known as first one is it is fundamental equation of kinetics. Newton's second law of motion is known as fundamental equation of kinetics. The second method is work energy principle, and third method is impulse momentum method. These are the three methods of solving kinetic problems. And after discussing this, let us look at the content of the syllabus, what you have in engineering mechanics. So the very first topic of this is we are going to understand the basic concepts of engineering mechanics, and we are going to discuss the principles of mechanics, and after that the detailed classification of system of forces, and it is broadly classified as coplanar system of the forces and non-coplanar, and mainly we are going to focus on a coplanar system of the forces, and in that how to find out the resultant of the system of the forces, and then equilibrium of system forces. This is very first topic. And the second topic of syllabus is analysis of perfect frames. Analysis of perfect frames. And in this we have two methods of analysis. One is method of joints, the other is method of sections, and by means of these two methods we'll be finding out the forces in the members of the truss or frame. And then it is the friction, concept of friction and laws of friction, and applications. So mainly we are going to discuss the applications is concerned wedge friction as well as screw friction in this particular subject. And you have, then it is centroid and center of gravity. This is the property of the area. By using first moment of area, we will be locating the centroid of plane areas, and of course center of lines as well as volumes. And in this we are going to discuss even Pappus theorem also, Pappus theorem 1 and 2. And then comes it is fifth topic is area moment of inertia and mass moment of inertia. So we are going to discuss in detail about area moment of inertia. This is one of the important, very important topic as far as mechanics of deformable bodies is concerned. And mass moment of inertia, it is the prerequisite for the dynamics of rotation. And then comes it is kinematics. Just now, as we have seen that it is kinematics is geometry of the motion, we are going to consider only the parameters. Let us assume that a particle is thrown into air at certain angle with the horizontal. We call it as projectile, and that projectile motion we are going to discuss in kinematics that it is the range covered by the body, the height reached by the body, and the time taken. All these comes under kinematic parameters, and that we are going to discuss in kinematics. So we are just focusing on the geometry of the motion only, and then the last topic is kinetics. In kinetics, we are going to discuss the kinetic problems by fundamental equation of kinetics. Newton's second law of motion is also known as fundamental equation of kinetics, and that equation, if you write down sigma fx, this equation is it is sigma fx is equals to mass into acceleration, is known as fundamental equation of kinetics. If you write down that mx double dot, mass into acceleration, to the left hand side, then the system is said to be in dynamic equilibrium, and that concept is known as the D'Alembert's principle. And you will be solving either Newton's second law of motion, which is also known as fundamental equation of kinetics, or by D'Alembert's principle. That is first method of analysis of kinetic problems. The second method is work energy principle, and the third method is impulse momentum method.